So the next topic is torque. We have already studied in school physics that the turning effect is produced when a nut is tightened with a spanner. The turning effect increases when you push harder on the spanner. It depends upon the length of the spanner. The longer the handle is, the greater is the turning effect of force. The turning effect of force is called moment or torque, and its magnitude is defined as the product of force and perpendicular distance from line of action to the pivot, which is the point O around which the body rotates. Thus, this distance OP from the center of the spanner to the moment arm length L point P. Thus, the magnitude of the torque is represented by torque T is equal to L into F, where the line of action of the force passes through the pivot point. The value of moment arm L is equal to 0, so torque is 0. We now consider the torque due to a force F acting on a rigid body. Let the force F acts on a rigid body at a point P whose position vector relative to the point O is R. This is the point O, and the position vector is relative to the point P is R. F can be resolved into rectangular components F sin theta perpendicular to R and F cos theta along the direction of R. The torque due to F cos theta about the point O is 0 as the line of action passes through the point O. Therefore, the magnitude of the torque due to F is equal to the torque due to F sin theta only about O. Therefore, torque is equal to Rf sin theta. This vector is resolved into two mutually perpendicular components. One is F cos theta and other is F sin theta. So question, it can be seen that the torque can be defined by a vector Rf inch Rf sin theta is equal to Rf sin theta is equal to direction of the by and divided by mechanism Rf. Thus the unit of torque is Newton meter. Just as the force determines the linear acceleration produced by a body, the torque acting on a body determines its angular acceleration. Torque is the analogous of force for rotational motion. If a body is at rest or rotating with uniform velocity, the angular acceleration will be 0. In this case, the torque is the analogous of force for rotational motion. If a body is at rest or rotating with uniform angular velocity, the angular acceleration will be 0. In this case, the torque acting on the body